All right, this lesson is on the sum of an arithmetic sequence. There is a formula in the yellow box. The S sub n represents the sum of some number of terms. N is the number of terms that you want in your sequence divided by 2. A sub 1 is the value of the first term, and then A sub n is the value of the last term. So example 4, find the sum of the first 100 terms of this sequence. So the value of term 1 is 1. And then we have a pattern of 1, 3, 5, 7, and then dot, dot, dot. And we need to find the value of the 100th term in order to use this formula up above. So in a previous video, we worked with the general formula. So the general formula is A sub n equals A sub 1 plus D times the quantity n minus 1. So we want to find the value of the 100th term. So A sub 100 equals, the value of term 1 is 1. The common difference going from one term to the next, you're adding 2 to the previous term. So the common difference is 2. The value of the term we want is the 100th term. So you can just put in 100 in for n. Now we're going to go ahead and simplify this. So A sub 100 equals 1 plus 2, the quantity of 100 minus 1 is 99. 1 plus 2 times 99 is 198. Simplify it and you get 199. So the value of the 100th term, the last term in the sequence, is 199. Now we're able to use this formula up here. S sub n equals the number of terms divided by 2, the value of the first term plus the value of the last term. So we're substituting in the sum of these 100 terms, 100 terms divided by 2. The value of term 1 is 1. The value of the last term is 199. And we do our orders of operation. So we're going to simplify. 100 divided by 2 is 50. 1 plus 199 is 200. Multiply 50 times 200. And the sum of these 100 terms is 10,000. All right, continuing on. Here's example 5 where we have summation notation with our sigma. So what does this represent? There are 25 terms in this sequence, and this piece here is your general formula. So if you think back to the general formula, A sub n equals A sub 1 plus D n minus 1, that's the general formula. So what we need to do is we need to find the value of term 1 and the value of term 25. So we're going to substitute 1 in for I. So A sub 1 is 5. Replace the I with 1 and then minus 9. Simplify it. 5 times 1 is 5. Minus 9 is negative 4. So the value of the first term in this series is negative 4. Now we need to find the last term, which is 25. So the value of the 25th term. We're going to replace that I with 25. 5 times 125, or 5 times 25 is 125, and then minus 9. 125 minus 9 is 116. Now we're able to go ahead and find the sum of this series. Now this series is 25 terms. So we're going to go ahead and use our formula here. All right. So I'm going to write the formula down. S sub n equals n divided by 2. Quantity, first term, and last term. Now we sub in. The sum of these 25 terms, 25 divided by 2, the value of the first term is -4, the value of the last term is 116, and then there's all of those terms in between. We don't have to find all of the terms in between. These are order of operation. 25 divided by 2, 12.5. -4 plus 116 is 112. Multiply those numbers together and you get 1400. So the sum of these 25 terms is 1400. Now you can check your answer if you'd like with the graphing calculator. So I'm going to show you how to do that next. So doing that previous example here. So here's our sigma notation. I'm going to change that to the letter X, and then 5x minus 9, and there's 25 terms. All right. So where you go is in your math button right here, and you're going to scroll down to summation, sigma. So right there, enter, and it's asking you for alpha. I'm just going to choose the variable x, and that first number is 1. And then how many terms we have is that top number, 25. And then we're going to put in your general formula. So 5 alpha x, whoops. Oh shoot, I just deleted it. Go to math, summation, x, 1, 25, and then 5x minus 9, enter. And you'll get that 1400 right there.